So let's focus our Riemann sum trapezoidal sum FRQ rewind with the trapezoidal sum. And my experience is the trapezoidal sum isn't going to usually be equal subintervals when you're dealing with the FRQs. Now, if it's in the multiple choice, it could possibly be equal subinterval. Well, let's break this one down. 2010, number 2, we can use the calculator. They had a zoo. It's sponsoring a one-day contest to name a baby. So they had a special box that zoo visitors could deposit their name in for the baby elephant. And they're telling you that it was between noon and 8 p.m., so 0 to 8. It looks to me like our units are just from the table. If I want to do rate, it would be 100 entries per hour. That would be a rate, but this isn't a rate table. This tells you how many entries are in the box T hours after noon, and that's what this models. All right, so that's how they collected this data. All right. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t is equal to 6. Show the computations that lead to your answer. Well, this isn't that hard. That just means I want to estimate a slope using a secant line for the E of t, right, on a given interval. And the given interval I want is between using 5 and 7 because 6 is between that. So I would want them to show that to estimate E prime of 6, I'm going to plug 7 in to E, subtract plugging in 5, change in Y, all over change in X, which is 2. Now remember, we do get a calculator, but sometimes we don't need it. And in this one, we don't. 21 minus 13, all over 2. That would be 8 over 2, which would give me 4. And that would just be 100 of entries per hour. Let's see if I can semantically say that right. 100 of entries per hour. Well, that was simple. You'll see they threw a twist on this one. They made it hard to get all the points for this one. You'll see. Use a trapezoidal sum with the 4 subintervals. So trapezoidal sum with the 4 subintervals given by the table. So I got to go trap by trap to approximate 1 over 8 times the integral from 0 to 8 of E of t. And then using correct units, explain the meaning of that in terms of the number of entries. So do the approximation and then interpret that in the context of the situation with a sentence. All right, so let's start way over here. 1 over 8 times the integral from 0 to 8 of E of t dt would equal 1 over 8 bracket, well, hold on a second. I want to approximate, so let's be consistent. We want to use approximate. Trap by trap. All right, so I'm going from 0 to 8. So the height of my first trap is 2. My bases would be 0 and 4. Half of the height times the bases added together would give me my area of my trap. So my first trap would be half times the height of 2. Remember, it's sitting on its right angle. It's sitting on its height on the x-axis. And then 0 plus 4 is 4. Plus, my next trap would be half. The height of the trap would be 3, which would be the width from 2 to 5. And then my bases added together would be 17. Those are the function heights added together. My next trap area would be half. All times width of 2 would be the height of the trap. And then the function values would give me my bases added together, which would be 34. Last trap would be half. That would have a height of 1, that trap. And then the function heights would be each of their bases. That would be 44 added together. Now remember, this is number 2. I get my calculator. I am not trying to do this one by hand. Control divide, 1 over 8. I'll put 8.0. I want a decimal answer. This is calculator. Parenthesis. I can now watch. I can do this in my head. Half of 2 is 1 times 4 is 4. Plus, this becomes 51 over 2. Control divide, 51 over 2. So I can save myself a little bit of key entry. Half of 2 is 1 times 34 is 34. And then half of 44 is 22. Just do a double check. And then that gives me 10.688. And that's just, remember, this is just going to go back to hundreds of units. Integrate, come back, divide by the. So we should be good. Don't overthink this one. So this would be hundreds of entries. So let's interpret this. Just use their notation. 1 over 8 times the integral from 0 to 8 of e of t dt means, remember, this is an average value, so means the average, and let's think about this for a second, the average number of entries in hundreds now use their words in the special box, or A, whatever, between noon and 8 p.m. Now, I've seen a lot of my students use t is equal to 0, t is equal to 8. Use it in the context of the actual situation, noon and 8 p.m. That's a better way to deal with it. Nothing crazy yet. At 8 p.m., volunteers begin to process the entries. They process the entries at a rate modeled by the function here. Now, be careful. They process the entries at a rate. So this is a rate for processing it. This is also in hundreds of entries. Now that's from 8 to 12. According to this model, how many entries had not yet been processed by midnight? All right. There were none here, right? So let's talk this out. Watch what we do. Unprocessed entries at midnight. Equals. Well, how many were sitting there at the end, right, at 8? Well, they didn't start processing them until 8 p.m. But there was 2,300. But you don't write 2,300. It's already assumed in the units that it's 2,300s of entries. So you would take the 23, and then you would subtract the integral from 8 to 12. So they're processing after maybe the part closes. Now remember, P of t is a rate. So we want to integrate that rate of processing these entries from 8 to 12. We want to integrate that. And let's see where we're at. So let's use our calculator on this. That would be 23 minus menu calculus. You would go integral, and you would go from 8 to 12. P of t, just be careful when you plug this in. I just always use x's, x cubed minus 30x squared plus 298x minus 976 dx. Let's just do a quick double check. That's x cubed minus 30x squared plus 298x minus 976. Well, that gives me 7. But remember, that's in hundreds, so that would be 700 entries. And I would probably write just a quick sentence on this. I would put 700 entries. Remember what we're answering. Had not been processed. That's what we want. Had not been processed. We started with how many were in there. We subtracted how many we accumulated as processed, but there were still 700 left. So 700 entries had not been processed at midnight. All right, here's where they made it hard for students to get a perfect score because you had to be on your game here. Let's talk fundamentals. According to the model from part C, at which time were the entries being processed most quickly? So I want to know when the rate is at a max. So I would let them know, okay, I want to know when P prime of t is equal to 0. And when does that happen? But I want to figure out where that happens on the endpoints. And you're like, well, what are you talking about? I'll get to that in a second. But look, this is a pretty easy cubic here to take a derivative of, because I want to look at this graph. You'll see why. I want 3t squared minus 60t plus 298. That would be, just do a quick double check. 3t squared minus 60t plus that. I want to know when that's equal to 0. So let's go to my graph. Now watch what I do here. So we're going to go menu, graph entry, edit, function. Let's plug in the derivative, which was, sorry, I can't see it, 3x squared minus 60x. Now you're seeing why I leave everything in terms of x, because I can go back and forth between my scratchpad and my graphing utility. Just do a quick double check, make sure I didn't plug anything in wrong. Something's happening over here. I mean, I know it's a parabola opening up, but let's set it to my restrictions. So it has to go from 8 to 12 closed. That's why we got to talk about this. Windows zoom, Windows settings. Let's go from 8 to 12. I don't care. I don't need to go much very high or very low. I'll just go from -3 to 3, 1 to -1, whatever you feel you need to do. Sorry about that. I'm not resetting this. We'll just scale it at 1. All right, so there she sits, right? So I know it equals 0 there. Well, here's my max. This is f prime graph analysis, right? It's really the derivative of the rate, finding the max of the rate. It's changing from positive and negative here. There's my max I got to check. This is a min. I can get rid of that, but I'm going to show them that I saw that it equals 0 there. So if I go menu, analyze graph, 0. I'm going to go to the left there. Now notice I don't hit enter again. This would be 9.184. And t is equal to, hit escape, menu, analyze graph, 0. Let's go over here. Hit enter, come back over here. And we get 10.816. Now remember, this is the derivative graph of the rate, right? So the rate's max is occurring here. I know that this is some type of max, right? And this is some type of min for when my rate is processing fastest, that'll be min. But I'm not going to include this in my analysis. And you're like, well, what are you doing? Here's where this got tough. This isn't the answer. This isn't the answer, and I'm going to show you why. And this is where you got to be careful. And I always tell my students fundamentally, like, you're trying to figure out when the rate has a max. P of t is the rate, right? So I need to check it at 8, the left endpoint. What is it being processed in the beginning? Also, because it's on a closed interval that it's processing, I need to check the right endpoint, and I only need to check my other max. This isn't an accumulation or anything like that. This is just watch this, just take your x cubed and figure out what that rate is at 8. So let's take our P of t, which is x cubed minus, whoop, I don't want to be up in there, minus 30x squared plus 298x, subtract the 976, put a plug line, and put x is equal to 8. 0. So the rate is 0 at the beginning. That's how they set up the model, right? Sorry, I'm a little cockeyed. Let's plug in the right endpoint. Sorry, I want to go back up, grab this. Didn't mean to do that. Let's plug in the 12. The rate that it's processing at the right endpoint is 800ths of entries per hour. So 800 an hour. Let's then plug in my interior, and I'm going to write something else up here that I should have, and I'll get to that in a second. Is equal to, plug x equals 9.184, and that gives me 5.089. That's, so the max processing rate, 089, sorry about that. That's 5.089. Transpose that one. So let's put this on the open interval between the endpoints. Let's let them know that that's what I looked for here. Then I set up my table to figure out what the rates were at the endpoints and at that max that I figured out, the relative max in this case. So actually the max is happening at 12. T is equal to 12. And a lot of people would have just put this 9.184 and been done. That's not how we get perfect scores. All right. You got to have fundamentals. If you're trying to find maxes on closed intervals, you got to check the endpoints. But this was a little trickier because you're trying to find the max of the rate, which means you had to go down another derivative to find other critical values on the interior. All right, according to the model, from part C, use their words, entries are being processed most quickly. Entries are being processed most quickly at t equals 12 hours. Well, thanks for that one, guys. All right. Hopefully this rewind helped you out. I hope you're a little bit better now at reviewing the left, the right, the midpoint, and the trapezoidal sum with ancillary topics in between. Keep on studying, and I hope this